Good afternoon, everybody, and welcome to our webinar on Prometheus applications. Unlock your Prometheus, exploring successful workflows. Thank you all for joining us today. Before we start, I'm going to give you a few words to introduce our speaker of today, Eileen Justiz. Eileen has a background as a chemist, and she completed her PhD at the Freie Universität in Berlin, where she gained experience with SPR and threat interaction studies. Further on, she did a postdoc on drug encapsulation in Bordeaux, and after that, since 2015, she's now working at Nanotemper Technologies, where after being responsible for academic accounts in France, Spain, and Portugal, she now covers the DACH and Benelux area, where she advises scientists about our applications and software solutions. Before handing over to her, I would like to give you some information on what you can expect to learn today. So in this webinar that will last during the next 35 minutes, we will give you extensive overview of possible applications of your Prometheus. But of course, in 35 minutes, we cannot cover everything what you can do with the instrument. So if you feel that you need more information or some of the application or in general, please feel free to reach out to us. Our contact detail will be given also during the presentation. So thank you very much. And now I want to introduce Eileen. Welcome, Eileen, and let's start the presentation.
Thank you, Leah, and thanks everyone for joining this presentation today, Unlock Your Prometheus, Exploring Successful Workflows. So let's start directly with the presentation with a question. So what is my personal Prometheus profile? This is defined by different things, like, for example, your usage of the instrument, the analysis of your data you gain, the software you are using, and for sure also the hardware you are using. So, but first, let's share some Prometheus customer experience. I want to share here some quotes from customers. So, for example, they found that Prometheus stood out like a champion when they were comparing similar technologies with Prometheus. Or also Thomas Schubert from Turbine finds that the unmatched resolution gives really high accuracy and reproducibility in his data. And Michaela Blech from Boehringer Ingelheim finds that Prometheus works perfectly even for structurally very complex proteins. But today it's about you. It's about your usage. So where in your workflow you are currently using your Prometheus, and why or how you make the decision to use your Prometheus at this specific project. Who is making the final decision? Is it yourself? Is it a technician? Or are you working as a CRO and your customer is requesting a nano DSF analysis? Who is operating the device? Is it yourself? Is it a technician? Or again, are you handing over your samples to a CRO who is performing the experiments? And finally, how often do you use Prometheus? Is it in your daily routine? Do you use it weekly or rarely just for specific projects? Together with the usage, also the analysis is strongly connected. So when do you use your Prometheus in your workflow is also when do you analyze your data? Do you compile all your data? Do you perform a day-to-day analysis of all your data, or do you just doing a quick check, so is my protein still okay? And the results, are they used finally for internal validation, or do you have to present them externally? Another important point is the hardware. So which instrument you are using? Are you using the Prometheus NT48 or the Plex? Are you in need of the aggregation optics, or do you have the high temperature option on your device? Or finally, do you need a full automatization and using the anti-robotic autosampler to have a long walk-away time? The fourth component is the software. So there are different software solutions which we will present together with the applications. You will always find the icons in the right corner here, which software was used. So we will go into detail during the applications. So now let's dive into the applications. So we have different solutions for protein characterization if you know nanotemper technology. So all over your protein discovery process, you can target specific steps in your workflow with the monolith, with the dianthus, with the Prometheus, and with the Tycho. But today, it's just about Prometheus. It's just about the applications of Prometheus. So for that, we want to concentrate on some specific applications in the upstream and downstream process, because the Prometheus is a device for every step in your workflow. You all have it already because you are Prometheus users. So the naming in your company, in your institute, in your group may be different from this. This is just an exemplary workflow to illustrate a general idea. So let's concentrate on the first steps when we are in the upstream process. For example, during expression, purification, screening, and assay develop optimization. So in expression, we are facing measurements in complex media. Here you see, like I mentioned, this experiment was performed with term control. So this is a normal experiment performed with the Prometheus. What we see here is we have an IgG within a cell supernatant. So the red curve is the empty cell supernatant, and the blue curve shows a high concentration, so like 30 milligram of IgG in this supernatant. So what we did here, we have decreasing concentrations of the IgG. You see this here, so we have the concentration of IgG decreasing, and here we have the inertial ratio. So what you see here is that down to a concentration of 1 milligram, which is here, you see an appearance of a second Tm. So you can determine the concentration of the IgG down to a concentration of 1 milligram per milliliter. So for this, I want to hand over to my colleague Lea, who wants to show you how you can perform this analysis, which you get from the term control with our new software PR stability analysis.
So thank you, Eileen. Yes, as Eileen said, I'm going to show you the concrete example of how such an experiment can be performed easily thanks to the software solution. So in this case, it starts with data acquisition with term control, which gives you the possibility to annotate and also to color code the several replicates of your measurements. And then we can move on to stability analysis software. This new software enables you to select a term control file. And when you open this file, replicates will be then merged automatically upon loading of the complete data set. So this is very fast, as you can see here. And afterwards, you see the whole data set of term control, and you have possibility to really customize and filter just for the right replicates you want basically to analyze. Here, by mousing over the different rows, you also can just display the trace, what you want to have a closer look at. And you have possibility to choose so-called key parameters, here the ratio and inflection points, to, of course, analyze the data. And the good point is it will then display them in a very easy to read plot, where you already see, for example, here a tendency in the initial ratio value to determine basically the limit of detection. You have also possibility to add or remove samples to these plots, and you can really easily read and analyze the data. After that, with one click, you can also export the whole data set and select the file where you want to export. So this is really fast and easy to make this data analysis now.
Thank you, Lea. So that we were speaking before of a complex media like in supernatant, we are now one step further. So after purification, we have to do something to stabilize our proteins. So, and for this, often we have to use detergents or additives. So for this reason, I want to show you now a detergent screen for integral membrane proteins. So there is a screen of around 25 detergents. And what we see here is a a screen of this detergent and the melting curve. You are all aware from your temp control software. And with this fast screen, we saw that the detergent has a strong effect on the stability of this membrane protein. So for this detergent, we have already unfolded protein at room temperature, and the DDM shows a melting temperature for the same protein around 63 degrees. When I'm talking now about screening, I also want to show you this example to give you a brief idea how much is possible within which time frame. So here is a screening of 2 antibodies in 96 conditions. So we have salt, no salt, and different pH. And this screening was performed in 2.5 hours with really high precision. So we have a really fast speed with the Prometheus of screening different conditions. These conditions can be also used for storage conditions, additives, adjuvants, assay conditions, for immobilization conditions or purification, or as well functionality tests. So this I want to show you here. So here we see a thermal shift compound screen of a GPCR interacting with a small molecule, and what you can easily see, you have here the purple curve or pink curve with no compound present, and then you see in the presence of different small compounds, you see directly in a dye-free ligand screen a thermal shift of your GPCR signal. So when we were talking about targets in pharma industry or biotech companies, I also want to mention the biosimilar profiling, as this is also a really hot topic for some companies. So together with UGA Biopharma, we did a biosimilar profiling using nano DSF, and you could easily compare the originator with the biosimilar in a really fast screen. So for this, Leah will show you another example.
Thank you, Eileen. Yes, here I really want to highlight how easy it is now to compare a sample with a reference. Basically, here we, of course, take a biosimilar candidate. So again, you load some term control file, and I want to show you some tips and tricks. For example, here there is a typo. You can also easily correct it directly in the stability analysis software. And this you can use for any type of analysis, basically. Also, by mousing over the row, you can exclude data where you see there are some bubbles or dust on the capillary. This is also very straightforward. You can select display options. Here, scattering is not relevant, so you can remove it really easily, for example. And afterwards, you can remerge, for example, where there was a typo, the new reference replicates. And you see it's also in real speed quite fast. And after you merge now the reference samples, you can assign this as a reference with one click on the top left of the window. And now everything, every data is basically compared to this sample, and you have a new column in the table called similarity, where you can display from highest to lowest the different samples in comparison to this reference. It gives you a value in percentage, but you could also select key parameters like inflection point and the similarity percentage to display again the values in a plot. So here again, to show you really how easy it is to read out the data, and you can directly identify that sample 11 is the best biosimilar candidate, which you can of course confirm by looking at the trace on the Prometheus data. And then you can show also reference delta, which is now also showing you all the parameters, so the onset of melting, the inflection points, as a difference between the reference value. So instead of having 60 degree or 55 degree, you have the value of -1, meaning sample 11 as -1.76 degrees of difference compared to the reference data. So this could also be very, very useful when comparing different samples. Thank you.
Thank you, Leah. This was really a nice application, I would say. So really fast, and to just connect it to the beginning. So here I want to highlight when I ask who is using the device. So it's often really important who is analyzing the data, who is looking on it. And here, if we have a software determining the percentage of similarity, I think this is really something, it's numbers what we can talk about. We don't have to trust our gut feeling. We really see hard numbers. So I think this software gives you a good basis to discuss also in your working group and present the results with a solid base. So to continue here, when we talk about comparison of data, and Leah showed the biosimilars, another important point is to compare also, for example, antibody-drug conjugates. As when I'm doing the synthesis of such a conjugate, I want to see if the conjugation was working well and if my protein is still in good conditions. So what we see with a high resolution of the Prometheus is that we see a domain-specific destabilization by conjugating the drug to the antibody. The same you can use also to check, for example, if you have to label your antibody or your protein and for other things. Another application of nano-DSF is also in the enzyme field. For example, you can check also for stability and activity. Here, together with the Jülich Forschungszentrum, we compared the nano-DSF data together with the enzymatic assay. And what we found out is in the nano-DSF assay, in the presence of DDM and OGG, we get a clear melting curve, which you all know from your Prometheus assays. But here, in these two cases, we just see that our enzyme is unfolded. And as expected, we also see in the enzymatic assay that we don't have any activity for this enzyme. So just in a really fast dye-free screen, we could see we could check the activity of these membrane-bound enzymes. So like I showed you now, or I hope to show you, we have one device for every step in your workflow. You have it already in your hands, like I showed you. You can use this for storage conditions, for a first estimate, do I have my protein in the cell supernatant during expressions? You can check for assay conditions to immobilize, for example, for your SPR experiment. And you can use it in every step nearly. So let's continue with some other applications, for example, in the downstream processing for stability prediction, formulation, quality control, upscaling, and process development in general. So first, we want to jump into the stability prediction. So here we want to talk about the chemical denaturation of antibodies. And we state here that delta G is a measurement to predict long-term stability. So if delta G is increasing with increasing concentration, the native state aggregation stabilizes the protein's folded state. And if delta G is decreasing with increasing concentration, the irreversible denatured state. If delta G is independent of the concentration, we are expecting no aggregation propensity. So here I want to highlight this is a delta G experiment, so you can perform this experiment with chem control. So what we see here now is the work of Boehringer Ingelheim, where they compared 5 different formulations, and what is outstanding here is the formulation 4. And if we compare it also with the monomer concentration on the long-term storage, because what we saw before, it's just like an experiment which is performed within a day or even less at different formulations. And here we see this is the monomer concentration of the different formulations. Also here, F4 is showing the best behavior, and also in the turbidity assay over 70 months, also F4 is showing the best performance. So the experiment before predicted already what we see in the long-term stability. Another capability of Prometheus is that Prometheus is able to determine at the same time the aggregation. And as well for this formulation, I want to highlight this. Again, we see here formulation 4 as with a high melting point for the first domain and also the second domain. And also in the aggregation, we see the aggregation occurs at the highest temperature also for formulation 4. So all data is saying what we see later on in the established turbidity measurement and monomer concentration determination. F4 is the stable formulation. If we talk about stability of proteins, we have also something else what we should keep in mind. This is buffer independency, or if we work with proteins like, for example, enzymes, which are producing, for example, some products like here, it was measured the stability of this enzyme in the presence of methanol. So the black curve is the enzyme in buffer, and then with increasing concentrations of methanol, we see a change of this enzyme. This enzyme was engineered to get a more stable enzyme, and here we also see with this mutant we could achieve a higher stability towards methanol. This is also an experiment you can perform when you do a drug screening, when you work with small compounds and your small compound is just soluble in ethanol, methanol or DMSO. Check before if your protein can stand this concentration of DMSO and if it's still folded and in an active state. When we are talking about enzymes, one important point is also that enzymes have to be highly stable. For example, when you use enzyme in cleaning products or whatever. So, and for this, the high temperature unit can be interesting for you, and also the capillary sealing, as you can heat your samples up to 110 degrees Celsius. This still with a really high precision and reproducibility you are used from your Prometheus device. To use the Prometheus in quality control is really important, because here you can easily quantificate your amount of unfolded protein. What we see here is a membrane protein freshly prepared, and then the long-term stability. Directly at the initial ratio you can determine how much unfolded protein you have. What we were investigating here was once a batch which was stored at room temperature and one batch incubated at 4 degrees, and you easily see even after 35 days at 4 degrees we have nearly 0 degrees of unfolded protein, 0% of unfolded protein, sorry, and at room temperature after 35 days nearly 12% of the sample are already unfolded. But not just storage is important, it's also important to have a look and to know what is forced degradation doing to my protein. You can test with Prometheus your protein sensitivity to different stresses. What we see here is we have our protein at room temperature and 1 hour at 4 degrees, no difference. Already 1 minute of vortexing, if you compare the initial ratio, you get around 5% of defolding in your protein. After 15 minutes at 60 degrees, completely unfolded protein. And also 10 minutes freeze-thaw, it's the blue curve, you get around 75% of unfolded protein in your sample. Never trust again your gut feeling. Check your protein, what it's capable for. For example, during purification or assay preparation, what does it have to survive? Check it before, and then you know my protein is still fine. Stress can be also applied during purification processes, as normally you store it at 4 degrees and during purification you can just handle it at 25 degrees. So with this you can use term control to mimic your processes. So for example, having a stepwise increase of the temperature and check how your protein is behaving. Or with the increasing temperature gradient, increase stepwise and check until when your unfolding is still reversible. Or in your process, check at which concentration your protein still unfolds and folds upon heat stress. This you can predict, for example, if you have to have a membrane filtration at room temperature and your concentration is increasing. Be sure that your protein behaves still good until your working concentration is reached. So to summarize it again, so Prometheus is one device for every step of your workflow. In the upstreaming process like expression and screening, in the downstream process where you do your quality control, your upscaling, your process development to get your final product with Prometheus. If you saw now anything which you found interesting and you were not aware of, for example, if you work with stable enzymes or antibodies, just reach out to us and we can tell you more about the high temperature add-on or the aggregation optics. Here, write us at service@nanotemper technologies. Or also when you have questions about the software. So for example, for the PR stability analyze software, we have a special launch offer until end of March when you want to merge your data, when you want to standardize templates and batch upload. So if some of these features of the software are missing to you, please reach out to us. And another thing I want to highlight here also is our support community. Please be invited to be an explorer. You find in our support community manuals, FAQs, videos. Also, we will invite you to webinars like this, show you tips and tricks and share user protocols. So join our Nanotemper Explorer community and be ready for takeoff to explore new applications in your current workflow. Be an explorer, see how you will use Prometheus in future, how you will analyze your data, how you will make the best out of your software and hardware to reach your goals, to take off to your perfect product. Thank you for your attention. Thank you, Leah, for showing us the software, and see you soon. Bye.